So we're going to start chapter 7. Exam will be over just chapter 7. I don't think it's maybe up to 7.5 or 7.6. I'll check later. Oh, actually, you check. 7.5. Yeah. 7 through 7.5. So we'll probably do 7.1 today, 7.2, and maybe 7.3 Wednesday. Next week we'll probably have that test. So it's gonna come quickly. That's the plan anyway. But that Friday off is gonna mess with my schedule, so we'll see how I feel by Wednesday or next Monday. I'll give you a legit date on Monday. Okay. Anyway, your exams probably won't be graded for a while. I have a lot of homework to grade. I'm a little behind. Yes. We have Friday. What's that?
Well, you won't be in this class.
Oh, Thursday, Friday, where campus is closed?
Yeah, like Holy Thursday.
I don't know.
Yeah.
Okay.
I probably got Easter Monday out too.
I think it's Thursday, Friday, and Monday.
Is it?
Yeah, it's
Yeah.
Thursday, Friday.
I mean, that sounds awesome, but I don't know. Huh. Well, I'll double check, but that might be right. I know for sure Friday.
Yeah.
We won't have class, but that will for sure throw all kinds of wrenches. Well, we'll figure it out. I'm not a planner anyway. Okay. So this section or this chapter is the first time you kind of see what math is really about. It's not about solving equations. It's not about numbers. It never was. It's about proving things that are true. So high-level mathematics, like graduate level, PhD level, all of that stuff, all we ever do in those classes or when we write papers is prove a statement using logic, theorems, etc. So all the formulas that we use, all the formulas in the books, those were all proven a long time ago. And mathematicians nowadays, modern mathematicians, are proving new stuff that are used in engineering, physics. Sometimes we don't even know what we're proving, but it becomes useful 200 years later. Which happened with Boolean algebra. Guess who's playing? Boolean, and like that stuff was proved a few hundred years ago, created. Was not used until we had a purpose for, which was circuits and logic gates. Sometimes we just do stuff for fun, and it turns out it's actually useful. Anyway, let me give you all the properties. A lot of the old school mathematicians were not mathematicians, or at least some of them. They were lawyers who did math on the side, just because. So logic is very, very necessary for being an attorney. I don't know if you guys ever read a contract, right? It's very complex, a lot of logical statements. You need to understand logic in order to know what you're signing or dealing with. Also, when you argue with somebody, right? Whenever you argue, I've noticed pretty recently.
Found it.
Found it? Oh, really? Cool.
Yeah.
You're looking for the date. Pretty easy. All right, then, study. So I guess we'll figure it out next Wednesday. There's no class Friday or Monday. Weird. Sorry.
No class on Thursday.
Oh, yeah, sorry. Yeah.
On the 14th?
I think it says Thursday evening.
Yeah, no, evening classes.
Yeah.
On the evening of the 14th to 18th, there are no classes.
Yeah. All right. I'm gonna give you all the identities. This is trigonometric identities. So it says on top. So we're not solving for anything here. We're just trying to prove one side is equal to the other side. So when we start doing problems, you're gonna have to refer to all your identities and see which ones can help you. And you don't work on both sides. Even though we have an equation, you pick a side, and then you get to the other side. Some of these I've already given you, but I'm gonna put them all here so we can look at them. There. Yeah, I've noticed recently, because I like arguing with people, it's very logical, so it's fun for me. But it's also not. But you got to be careful who you argue with. If people get pissed off. Yeah, I mean, sure, it can be, but most arguments I've learned in the recent years can be broken down to a disagreement on a definition of something. So, like, if you just stop and say, you know what are we arguing about? How do you define this word? What does this word mean to you, and what does it mean to me? And then that's what you realize, you know what? We just both had a misunderstanding of what we thought this meant. So there was no actual arguments. You just pile a bunch of garbage on this one concept. And the argument gets out of hand. But in reality, there's just a small disagreement on the definition of something, whatever that is, right? So sometimes it's good to take a step back and figure out, okay, what is that person talking about, and what does that mean? What does this mean to them? I find that pretty helpful in recent years. I could spend like an hour, debating something. Then I realized, you know what? I could have saved a lot of time if I would have known that he thought the sky was green, or whatever. Or sometimes I thought this word meant something else, and then I could have just looked it up, save some time. These are ratio identities. These are the reciprocal. Gave you all 6 just in case. We're going to be using all of these today. Pythagorean. Look at I've given these to you as well. So all of these 9 formulas that I'm about to write come from this original one. This is the famous one. Sine squared plus cosine squared equal to 1. So doing a lot of algebra on this guy creates 8 more. Okay, so the basic algebra would be subtract cosine, right? That gives me this guy. Subtract sine. That gives you this. Now, if you were to divide everything by, let's say, cosine squared, right? Let's say I divide every single term by cosine squared. That would give us this, right? Sine over cosine would be tangent. Cosine over cosine would be 1. 1 over cosine would be secant. So then just move those around. You create 2 more. Solve for tangent. Subtract the tangent, get another one. Solve for the number 1, I guess. Okay, now if you divide by sine, you create this one. Sine over sine would be 1 plus cotan equal to cosecant. And then just move those around, you get 2 more. Subtract cotan, subtract 1. And you don't have to know all the details, but that helps to understand how they were created. That way you can use them better. But if you just have them out, have them ready and just use them, that's fine. one of my favorite professors, he started a prep program. I don't know if you guys ever heard of it. He wanted to make sure that everyone studied logic. So he always had like a section of logic in prep.
Wait, so,
Really
third column,
Yeah,
is that the first equation divided by what?
this one right here,
Yeah,
this column is you're dividing the original by sine,
by sine,
sine squared.
and the other one you're divided by cosine squared.
Yeah, so that's how they're created. And you just rearrange them using subtraction, and you'll have the other two. Okay. Does everyone see that? Okay, let me show you real quick. We'll come back to it. Let's say you have the original, and I divided everything by cosine. That's the second column, right? So this becomes tangent. This becomes a 1. This becomes secant. That makes sense? That's where this first equation came from. So then I can subtract 1 and get the other one. Now, if I take the original and divide by sine, right, everything by sine squared, I get 1 plus cotan equal to cosecant. Okay, that's what's happening in the background. So you do that, this creates the second column and the third column. Right? Just in case you're curious, that's where these two came from, and then you just do subtraction and find these two here. Okay. Even and odd properties. I believe I've given these to you already, but the book wanted me to talk about it again for some reason. So I'm going to write okay. Sine of negative x is equal to negative sine x. So this is an odd property. Okay. If you take the reciprocal cosecant, we'll have the same property because they're basically the same, they're just reciprocals. Be negative cosecant x. Cosine is the only one that is even. So it'll be cosine of negative x. So it just absorbs a negative. This is the even. We want to make a note here. This is the even guy. Secant is a reciprocal, so it'll have the same property. Absorbs negative. Tangent is odd, and so is cosine. So everything is odd except the middle one. Okay. The last one will be the co-function identities, and we'll get to the examples.
This is co-function.
Co-function.
The third properties are how article.
This one?
No, the third one.
Third is Pythagorean identities. These are all the Pythagorean type stuff. So whenever you see some a trig function squared, come check these out. See if you can use them. Okay. All right. So that's sine. Cosecant
What is that instead of parentheses?
Here,
In the other parentheses.
and
Oh,
this,
that's cosine. I'm sorry.
oh yeah, this is a
Sorry.
cosine. Sorry, I'm writing a little small because there's so many of them. I'll write bigger in the next page, promise. Okay. So the reciprocal, right, it's just 1 over sine is cosecant, so it'll shift as well to secant. Cosine will go, of course, shift to sine, just like sine shifted to cosine. They are co-functions, that's what it means. If I do a horizontal shift, it turns into the other function. Alrighty.
Is it pi over 2 minus x?
Yeah, all of them are pi over 2 minus x inside the parentheses. Okay. So cosine pi over 2 minus x is sine. Secant pi over 2 minus x is cosecant. And then the tangent will be cotan. So that means cotan will be tan. This will probably show up on the homework, these types. So just in case you need them, they're all there. Okay. That was it. If you can't read it, let me know. I know I jammed a lot on one page. You guys okay on this page? All right. All right. So example 1. So my best advice I can give you when doing these is to just try something. Don't be scared to try something. I think that's the hardest part, to prove the following, that you just got to do something. Don't be scared to get something wrong. Just try something. Because there's no set of steps. I can't just tell you how to do this. You got to use the properties and identities and hope it leads you in the right direction. So you pick the path yourself. I'm going to show you certain techniques and recommendations for stuff to look out for. But you can take very many different paths to get to the same place. So not everyone will have the same answer. And some answers will be, simpler than others, kind of like when you do coding, right? Some codes are super short, some are ridiculous, but they do the same thing. Right? Some are more efficient, whatever. Who cares? So what you're supposed to do is pick a side. My rule of thumb is just pick the side that looks most difficult or upsets you the most. Right? Start there. Left side looks like trash. And let's pick that one. And let's start right here. Because if you choose the one that looks simple, then it requires you to be very, what's the word? I want to say gifted. Imaginative. So you pick a side and you need to get to the other side. You need to prove that they are equal using all the identities I wrote down on that first page. So first rule of thumb, pick the ugliest side. Sometimes you have two sides that are ugly and it doesn't matter. That's okay too. So I'm choosing the left-hand side. When you see a tangent, you should consider changing it into a fraction. Okay. So what is tangent equal to? So yeah, start here. Let's see, and then figure out, okay, what can I do here? I don't know. So I apply the ratio property here. Or identity. Okay. Now multiply that and see, and then we think about what else we can do. So sine times sine. Okay, so here we are. Sine squared over cosine is a fraction. So the next thing that you should think of, whenever you see fraction, is add them together and I hope something happens. That's another rule of thumb. You see a tangent, change it to a fraction. If you see fractions, add them together. Okay. If you see a square, maybe consider using a special Pythagorean. So let's add these fractions. What is the LCD? Yeah, just cosine. So we need a cosine down here, right? So introduce what we need. Add the fractions. Oops, sorry, I skipped the step there. So I'm just introducing cosine, adding fraction, that's what we're doing. So we get cosine squared x over cosine plus sine squared x over cosine. So same LCD, add the numerators. That'll give us cosine squared x plus sine squared x, right? So we have the same denominators, you can add the numerators. Any of the fractions, so make sure you ask me about the fraction steps if they're confusing you, because you're gonna have to be good at fractions here for this chapter. You can't avoid it here. You guys are cool with these steps?
How do we square cosine?
Oh, it's just when you so we introduce the denominator, right? So cosine times cosine gives me the square. 1 times cosine gave me that denominator.
Yeah, but cosine over 1 plus sine squared over cosine is, where do we get another cosine from? Wouldn't we have to do it to the other side too?
Basically, we're doing it on top and bottom to avoid having to do that. Like, so for example, let's talk about two things here. So if we're adding a basic numbers, right? Number one, if they are prime, you use the product, right? 2 times 3. So then that means that the LCD is 6. Now, in order to get that 6, introduce 3 over 3 on purpose, right? And the other one needs a 2 over 2. So I have to do it to the top in order to maintain that balance, because we don't have 2 sides of an equation there. We said we can only choose one side. I can't do both sides. So to get around that, I multiply top and bottom because this is a form of 1. This cancels out into a 1, so it's as if I did nothing. So that allows us to get around it. That makes sense?
Yeah.
The same thing we do with numbers back in the day. Once we have it, add them together. At this point, you should see it's the Pythagorean, right? Look at the page 1. What is that equal to? Yeah, it's going to be 1, right? So all this was just fraction stuff. This becomes a 1. So right there, here, we did Pythagorean. everyone see how that's Pythagorean?
Mhm.
We said sine squared plus cosine squared is 1. So this is 1. Now, what is 1 over cosine? Yeah, look at the reciprocals, right?
Mhm.
This is secant. So I'm not going to expect you to memorize all of those identities, like my professor made me do. I had to write down like 60 of them before the test started. It's horrible. But I do expect you to know how to use them. So as soon as you see something that might be familiar, go back to the page, right? 1 over cosine, we should go back and say, oh, that's one of these, right? There it is. So I swap it with secant. Okay. Then we get back here, change it to secant. So now I've shown through algebra and all those identities that that original piece was equal to secant. We've proven it. Okay. Yeah.
Can you go back to the trigonometric identities?
Yeah, sure. Any questions on this example? You see what we're trying to do here? You see the end goal? Any of the steps not make sense to you? Is it weird? We're not solving anything, we're just proving something to be true. That's why logic is fun, right? Once you're done, like nobody can refute it. That is the truth. No longer matters what your opinion is. Truth and facts are what they are. All right, you guys cool on this page then? So that's the first. So I'm going to try to show you different types of techniques on approaching it. So first one was change it to a ratio and add fractions. Next one will be multiplying stuff out and maybe do something similar. I don't know. Let's see. Prove that cosine times secant minus cosine is equal to sine. So what side would you choose, right? What's the obvious side to start at? Yeah, left-hand side looks like it's best, right? I mean, you could choose the right, but it requires a lot of out-of-the-box thinking to change this into this. So that would be a lot more difficult. It's possible, but I don't recommend it. I'm choosing the left because I have more to work with. So when I say more complicated, it means we have more things that we can do. Okay. So I'm choosing the left-hand side. Set it equal to. I suggest we multiply it out, right? There's a parentheses there. Let's multiply it out and see what happens. We get cosine times secant minus cosine squared, right? Nothing fancy yet. At this point, you should consider changing the secant, right? Back to ratios and reciprocals. What is a secant? Yeah, it's going to be 1 over cosine, right?
Can I post the times 3
Yeah, it is 1 because it's equal to 1 over cosine. right? They cancel out and become a 1. But yeah, whenever you multiply something by its reciprocal, it's always going to be 1, like 2 times a half, etc. Right? Same logic, same thing. This will be 1. These cancel. So what did I use here? We said reciprocal identity. Now, if your algebra game is weak, then this section will be challenging. So make sure you get that practice done. See a square, you should be thinking, oh, maybe Pythagorean. Which Pythagorean should I use? The 1 minus cosine squared is equal to, yeah, which is what we wanted to show. This right here is Pythagorean. Sine squared is equal to 1 minus cosine. Any question about any of the steps? After we finish the example, I'm going to give you something to try because it won't make sense until you try it. That's cool. Number 2. Number 3 is a little long. Yeah. Okay, so that was one example, multiplying stuff out and using reciprocals. The next one will be a conjugate type. You guys okay on this page? You remember what a conjugate is? Okay, so A plus B is the conjugate of A minus B. A minus B is the conjugate of A plus B. So basically it's the same thing with the opposite sign in the middle. That's all conjugate means. Is that clear? That's all it is. Nothing fancy. So what we're going to do in this example is use the conjugate to force a square to appear so we can have this situation. Okay, I'm going to rig the question. 2 tan secant. Show that that is equal to 1 over 1 minus sine minus 1 over 1 plus sine. Okay. So what side disturbs it? That's the side we should use. I think I forgot. Oh, it's times. There's a times in there technically. Yeah, this side looks pretty ugly. So I think that might be the better side. I mean, you might be able to, it might not matter in this one because they both are kind of complicated. This one bothers me. So I'm gonna choose that one. Choose that one. Okay, so start right here. This is one of the harder ones. But notice how we have conjugates in the bottom, right? This one is the conjugate of this one, the denominators. So that means when we start getting the LCD, they should square like this. Because when you multiply them, they always turn out to be like this. So we can skip the multiplication step, save time. If you choose to FOIL it out, it's going to cancel anyway, and you'll be left with this. Okay, so who cares? But these are prime, like we said earlier. If the denominators are prime, then the LCD is just a product. That's it. That's it.
The denominator, the first one to cosine first.
Cosine? Only if they were squared. You talking about the Pythagorean? Right now, I can't do anything. I'm going to force it to be squared, and then we'll do something like that. So once I introduce this, right, notice how that becomes this guy, right? Technically, that's how this would multiply, because they are conjugate pairs. So multiply the top and bottom by what this needs to get the LCD. Same here. Yeah, it's just square.
So it'd be like cosine.
Yeah, these can be changed to cosine. That's where we're probably headed.
Mhm.
So this one needs the plus. So make sure you do top and bottom, otherwise it's fake math, right? Keep balance. Minus. One plus sign. One minus sign. Okay, so we're just adding fractions. That's all we're doing. You guys follow me from here to here? Right, we needed the LCD, so I introduced what I needed. And the bottom part is going to turn into this. Right? Equals. So this will be one plus sine over 1 minus sine squared minus 1 minus sine over 1 minus sine squared. I skipped a minor step there. You cool with this? Do you see? You follow me? Yeah. At this point, the next step will be adding the parentheses.
How can you multiply one this side by one plus sine squared x and the other one by one minus?
So I need them both to have this in the denominator because that's the LCD. So this one needed the plus, this one needed the minus. That's the idea. Kind of like we had when we had the 1/2 plus 1/3, right? One needed 2, one needed 3. Okay. So now subtract the fractions. And they have the same denominator. Let's go and do it. 1 plus sine x minus. When you subtract fractions, you need to put the minus on the entire numerator. Don't just put it on one term. It'll mess you up. Okay. So distribute the negative. Then I go to the 1 plus sign minus 1 plus sign. 1 minus sine squared. Which will be 1 minus 1 is 0. Sine plus sine is 2 sine, right? Okay. So finally, we've added fractions. That took forever. We got it. Any questions on the fraction step? Now's the time to ask me about fractions. Don't feel bad because, like I said before, I have people in my calculus 2 class in my other job that can't add fractions. So people forget. It's cool with all these steps. Okay. So on the bottom, we have 1 minus sine squared. You see a square, what should we do? What identity can we use? Yeah, it's going to be Pythagorean. Yeah, so this is actually a 2 sine over cosine. It's almost Pythagorean. Okay. Now, it looks like we're almost there. We're trying to get to 2 tan secant. Yeah.
Why is it over cosine?
Why? Oh, the Pythagorean says that cosine squared is equal to 1 minus sine squared. So if you turn to page 1, we said that this was equal, right? So we got to this point and figured, okay, I don't know what to do at this point, but it looks like I have Pythagorean, which we did. So I did the substitution. I applied the identity. Okay, so now we're here. We want to get there. It looks like we're kind of close, right? Kind of. There's a 2. That's cool. What is tangent as a ratio? That's reciprocal. Ratio is
Sine over,
Oh,
yeah,
yeah.
sine over cosine.
sine over cosine. So we have a sine and a cosine, but it's a cosine squared. So this is what I'm thinking. This is a little, not a lot, but a little bit outside the box. Do you agree that this is the same? Actually, let me make it more obvious. Do you agree that this is the same thing? Right? I don't know why I wrote that so small. Right. Yeah. One more time. Write it big this time. Cosine times cosine. You agree that that is the same?
Yeah.
And you see that this is right. This piece right here is tangent, right? So then I can say this is 2 sine over cosine. Just break this piece out. So you know what? This is the same as 1 over cosine. Okay. So that is 2 tangent. This is, what is this? Secant. So right there we use the ratio and reciprocal properties that we wrote down at the beginning, or identities. Any questions on the algebra or this last step here? This is one of the little harder ones. Probably towards the end of the homework. It starts off a little more chill, so I promise. At this point, they're assuming you're comfortable with a lot of properties, but we're still kind of practicing, right? Still learning them. So don't feel overwhelmed. As I like to remind people, in every math class I've ever taken, I've felt confused and lost the entire time. Always felt that way. It didn't make sense till, I think there's a famous quote by a mathematician that said, mathematics is learned in hindsight. When you look back, it makes perfect sense. But when you're there, you're just like, I don't know what this is. Like if you look back at your college algebra, or when you're in calculus and look back at this class or whatever, it starts to make more sense. They also said that you learn mathematics in a spiral. So each time you go around it, your knowledge gets bigger. Okay. So you got to keep coming back to it. Eventually, you have a big spiral. Any questions on this page? I'm going to turn the page. Do one more example, then I'm gonna give you some problem practice. That way you can ask questions and try to figure this out. So cosine over 1 minus sine is equal to secant plus tangent. Okay, this is the one that I was talking about. We should probably use the conjugate. So if you see something like this, you should be thinking, okay, if I multiply by the conjugate, I can force 1 minus sine squared. And then I can force a cosine squared. Okay, so we're just trying to set it up. So I'm picking the left side because I see that 1 minus sine. That made me think I have something that I can try. Okay, I could have done this side. I think both sides would have been equally difficult. I don't think it matters in this example. But I'm choosing the left so I can show you the conjugate. If I chose it right, you would change it to fractions and add them, and it'd probably come out pretty quickly. We did the fraction step a couple of times, so let's do something different. So this is multiplying by the conjugate. So I'm doing it top and bottom, so I'm not violating any rules. Multiplying by conjugate. Okay, I chose the left side, multiplied by that. I'm not going to multiply it out yet on the top. You can multiply by whatever you like, on top and bottom, on any fraction, except for the number 0. Choose any variable or number, top and bottom. Okay. These two are conjugate pairs, so they turn into the same thing like always. 1 squared minus sine squared. So if you want to multiply this out, you can get this. I'm not going to do it because we've done it many times. You should know how to FOIL and multiply. And if not, let me know. So you see where we're going with this, right? We force that 1 minus sine squared. What is that equal to? Yeah, so we created a Pythagorean identity, or opportunity to use it, I guess. Right here, we apply the Pythagorean identity that cosine squared x is equal to 1 minus sine squared x, where x is just some angle. Who cares? Okay. So I changed this to cosine. Now everything is factored, so this cancels, right? And we only do cancellations when things are factored or they're exactly the same. I've seen a lot of you want to cancel stuff like this, sine, sine.
So cosine x and cosine squared x will cancel.
One of these cosines will cancel.
Okay.
Yeah. Or we're left with one more, right?
Mm-hmm.
We get to here. We're almost done. If you can see the trick to this. So far, I've been recommending you add fractions and combine them, right?
Mm-hmm.
Usually that forces something to appear, and then we can use another identity. This time, I'm going to recommend you separate the fractions, because over here, they get you to give us a hint. They have a sum, right? That's separate. So if I break these into 2 fractions, I should get this. You see? 1 over the cosine, sine over the cosine. All I did was separate the fraction. Yeah, 1 over cosine, sine over cosine. Yeah, and then this identity would be secant, and this would be tangent, right? Using the identity. So from here to here, we use the reciprocal and the ratio at the same time. Okay. Now, there's not just one way to do these problems. Again, just try something and see where it goes. Take that path, start walking. I don't want to just. What I don't want you to do is look at this and be like, okay, I don't know what to do. I don't know how to start. Just sit there. You just need to try something. Okay. And as you do more and more, you start to see patterns and certain ideas at work. Okay, so I've showed you some of them. So now there's some problems. So yeah, homework. Homework is 3 through 53.
This was 7.1.
7.1. So all of chapter 7 is going to be like this for the most part. Yeah, it is 7.1. 7.1 through 7.5 will be test 4. I don't know when that's going to be because we have all these days off. So we'll see how that goes. But I'll probably put these two homers due on Sunday. 7.1 and 7.2. I don't think we'll get to 7.3, but we'll see. You guys cool on this page? I'm gonna give you some practice problems. I want you to try them. If you don't try them, I'm gonna turn them into a quiz instead. So humor me, and I won't grade you, right? I don't like to force people to do stuff, you know. But this is good for you. It's your vegetables.
So are we treating this as being a cost?
Only if you want me to grade it as a quiz grade. But no, this is just for practice. The point is try to understand what we just did. Because until you practice this, it's not going to make a lot of sense. And it's fresh right now. But before you forget what I just said, please do this. And I'll give you some hints along the way. We got about 20 minutes. First two are similar, and I think pretty straightforward. The last two are fraction heavy. Okay, so first one, by new spirals. First one is sine theta over tangent theta. Prove that that is equal to cosine. I recommend you start on the left. Number 2 is tan theta over secant theta. Prove that that is in fact sine. Number 3, cosine over secant plus sine over cosecant is equal to 1. This is 1 over secant plus tangent plus 1 over secant minus tangent. Show that that becomes 2 secant. So all 4 of these start on the left side. As your first sentence, I recommend you change the tangent into a ratio. That's your first step, number 1. Assuming you all got to this point, right? So how do you divide fractions? What happens when you divide? Yeah, so the next step, you're gonna flip this guy, right? And then multiply.
You just cancel them.
That's why they cancel.
Okay, but instead of like doing all that reciprocal stuff, you can just like cancel the signs.
Yeah, but you need to make sure you don't mess up where that cosine goes.
Okay.
I'd prefer you show it that way
Okay.
you won't
Yeah.
make a mistake. That's the first step, right? Change the ratio, divide the fraction. So if your algebra is good, it shouldn't be an issue. But these become difficult when you forget your algebra. Number 2 will be very similar. Change the tangent and the secant, and you'll have two fractions. Just flip the bottom one and multiply. Because everyone got to here on number 2. Do you see what you have to do? Secant is as a reciprocal on page 1 is 1 over cosine. So that is the reciprocal identity. Tangent as a ratio identity is sine over cosine. So apply the identity on top and on the bottom for this original fraction. You're gonna have all your identities handy when you're doing the homework, okay? There's a lot of them. Did anyone finish number 1? Once you're left with just the cosine, you're done. This will be very similar. So flip this guy over. We get to here. Same thing happens. Is that clear? When you divide fractions, that's the rule of fraction division. So back in the day, right? 2/3 divided by 1/2, you would flip the bottom one, right?
I wish they would just, so even in the books, they say it's applied by the reciprocal, it should say the reciprocal of the denominator. That makes way more sense.
Yeah, it's always a reciprocal of what you're dividing by. That's true. Would you guys try number 3? Yeah, I would use reciprocal on the denominators. You guys get to this point?
Yeah.
Alright. Secant, right? Try changing it to the reciprocal. See if that helps you. Or if you see, or you could have taken a different path and said, you know what, I see fractions, maybe I should add the fractions. I think either way.
Or, it says that sine is equal to 1 over cosecant. So, or sine.
Say that one more time.
The sine always to the right. Up and down, then change to 1 over cosecant.
Because it's going from rectangle to cosecant.
Yeah, we changed cosecant into 100%. But you could go back. Doesn't mean that's true. Right? But we changed this one into that one. The numerator was, we left them as cosine and sine. We didn't mess them at all. We just changed the denominators because I saw a secant and a cosecant. That was the idea I had. That's not the only way to do it though. You could have introduced an LCD, right? Secant over secant, cosecant over cosecant. That would have worked just as well. I don't know which one's better, but it might be the same. Anyone have any question on these first two? Did those in the test? Not too bad. You see how this is gonna be the same type of deal, right? Once you change it. If you took this path.